All right, welcome to The Explainer. Today, we're going to demystify something we use every single second of our lives, but maybe don't fully understand: the internet. How does it actually work? Let's dive in and find out. I mean, really think about it for a second. You click a link and boom. In less than a heartbeat, information flies from a server that could be thousands of miles away, right onto your screen. How in the world is that possible? It feels like actual magic. Well, the answer isn't magic. It's a network, a massive, physical, very real system of interconnected hardware. And today, we're going to pull back the curtain and see exactly how this incredible system is built and how it all operates. So we're going to break this down into 5 simple parts. First, we'll ask, what is the internet, really? Then we'll look at the physical building blocks of the network. After that, we'll follow the amazing journey our data takes, understand the common language that lets everything talk to each other, and finally, we'll zoom out and see the big picture of how it's all connected. Okay, so let's start with that first big question. When we say the internet, we usually think of something kind of abstract, like the cloud, but the reality is much more tangible, much more solid than that. The best way to get your head around it is to think of the internet as 3 things at once. First off, it's a physical infrastructure. We're talking millions of computers, tons of cables, and all those routers. Second, it's a network architecture. You can think of that as the master blueprint, the set of rules and models that governs how everything connects. And third, it's the communication service itself, the very thing that uses all that hardware and all those rules to power the apps we can't live without. So now let's get into how this whole system is built. What are the actual physical components? What are the building blocks that make up this incredible global structure? First up, you've got hosts. You might also hear them called endpoints or terminals. This is just every single device that's connected to the network. Your laptop, your smartphone, of course, but also the huge, powerful servers out there that store all the websites and data. They're the starting point and the finish line for any trip on the internet. Next, you got to connect all those hosts, right? And that's the job of the links. These are the physical pathways for the data. It's everything from those massive fiber optic cables that are literally lying on the ocean floor to the invisible radio waves that connect your phone to a cell tower or a Wi-Fi router. And finally, our third building block, nodes. The most important type of node you need to know about is the router. So if the hosts are the cities and the links are the highways between them, then the routers are like these brilliant, super fast traffic intersections, directing every bit of data to exactly where it needs to go. Okay, so we've got the pieces, we have the hosts, the links, and the routers. But how does your email or a YouTube video actually travel across this gigantic network? This is where things get really, really clever. You see, early networks, like old-school telephone systems, use something called circuit switching. Imagine you had to book a private, dedicated highway from your house to your friend's house. While you're on your call, no one else can use that highway, even if you're both just sitting there in silence. It's dedicated, but it's incredibly wasteful. The internet uses a revolutionary idea called packet switching. Instead, your information gets chopped up into tiny little pieces, or packets. It's like sending a whole book 1 postcard at a time. All those postcards just get thrown into the public mail system, sharing the road with everybody else's postcard. And this simple chart just shows you what a game changer that is. On the exact same 1 megabit per second connection, circuit switching might only be able to handle 10 users. But packet switching, because it shares resources so efficiently, can handle 35 or even more. This is the core principle that allows billions of us to use the internet all at the same time. So here's how that whole process works. First, your data gets chopped into those small packets. Second, each and every packet gets stamped with the final destination address, just like a piece of mail. Third, the routers, our traffic directors, they don't need to know what's in the message. They just read the address on each packet and forward it along the network. And finally, all the packets arrive at their destination. They may have taken different routes, they might even arrive out of order, but the computer on the other end knows exactly how to reassemble them into the original message. It's pretty amazing. But for billions of different devices, made by thousands of different companies, to all communicate without creating total chaos, they all have to speak the same language. This is where protocols come into play. They are the agreed-upon rules of communication for the entire internet. Now, the most common setup for these conversations is the client-server model. It's pretty simple. Your web browser is a client, it makes a request for a web page, and the computer that's hosting that website, that's the server. It's on 24/7, just listening for requests and then serving up the data. What's really fascinating, though, is that these rules aren't just one giant, messy rulebook. They're organized into layers. This is called the TCP/IP stack, and it's really the secret sauce to the internet's power and flexibility. Each layer has a very specific job. Down at the bottom, you have the physical layer, the actual cables and radio waves. Then the link layer handles local traffic, like on your Wi-Fi network. The network layer uses the Internet Protocol, or IP, to manage addressing and routing across the globe. Above that, the transport layer makes sure data gets there reliably. And finally, at the top is the application layer where protocols we might actually recognize live, like HTTP for websites. Each layer builds on the one below it, which creates this unbelievably robust and adaptable system. This brings us to our last point, and it's maybe the most important one. The internet isn't some single giant thing that's owned by one company. No, it's something way more complex and, frankly, way more interesting than that. I really love this quote from our source material because it just perfectly captures the idea. The internet isn't one network. It's a network of networks. A puzzle of interconnected pieces. The entire global system is actually made up of thousands of separate, independent networks run by different internet service providers, or ISPs. Those are the companies you pay for your internet connection. They each own their own infrastructure, but here's the key. They all agree to connect to each other, passing packets back and forth to create one seamless global network for all of us. And so, this is where we end up. The internet is a technical marvel, for sure, but it's also a social one. It is a globally decentralized system that functions because of cooperation, because of agreed-upon standards, and a shared architecture. So the final question to leave you with is this. In a world that can often feel pretty divided, what can we all learn from this incredible collaborative machine that we've all built together?